Welding can generate electromagnetic interference, or ME, which can disrupt sensitive electronic equipment, including communications equipment. The EMI can travel through the steel structure that is connected to the ground ring and into the equipment. To minimize the impact of welding on communications equipment, the following isolation procedures are recommended. Firstly, physical separation. Place the communications equipment in a separate room or enclosure that is not directly connected to the steel structure. Use vibration isolating mounts or pads to reduce conductive vibrations. Secondly, electrical isolation. Install surge protectors and isolation transformers to protect equipment from voltage spikes and transient currents. Use fiber optic cables instead of copper cables for data transmission, as fiber is immune to EMI. Thirdly, grounding. Ensure that the communications equipment is properly grounded to a separate ground rod or grounding system that is not connected to the building's ground ring. Fourthly, temporary shielding. Before welding in areas close to the communications equipment, consider using temporary Faraday cages or electromagnetic shielding materials to protect the equipment. Fifthly, monitoring and communication. Install EMI monitors near the communications equipment to detect and quantify any interference. Monitor the performance of the equipment regularly to identify any potential issues. Inform the welders about the presence of sensitive electronics and the need for precautions. Coordinate welding activities to minimize the impact on the equipment. Sixthly, additional considerations. Schedule welding activities during off hours or when communications equipment is not in use. Use the lowest welding currents and shortest arc times possible. Use shielded metal arc welding or SMAW or gas metal arc welding or GMAW with low inductance cables to reduce EMI. Minimize the use of arc gouging or plasma cutting, as these processes generate higher levels of EMI. Considering physical separation, it's important to create a buffer zone between the welding activities and the sensitive communication equipment. This can involve relocating the equipment to a different room or constructing a physical barrier to attenuate the electromagnetic waves. Vibration isolating mounts and pads can further dampen the transmission of mechanical vibrations caused by welding, which can contribute to equipment malfunction or data corruption. Regarding electrical isolation, surge protectors act as a first line of defense against voltage spikes that may originate from the welding process. These devices divert excess voltage away from the equipment, preventing damage to sensitive components. Isolation transformers provide galvanic isolation, meaning they break the direct electrical connection between the power source and the equipment. This helps to block the flow of common mode noise and transient currents. Fiber optic cables offer inherent immunity to EMI because they transmit data using light signals rather than electrical signals. This makes them an ideal choice for data transmission in environments with high levels of electromagnetic interference. With respect to grounding, a dedicated ground rod or grounding system for the communication equipment ensures that any stray currents are safely diverted to ground, preventing them from circulating through the equipment and causing interference. It's crucial to avoid connecting this grounding system to the building's ground ring, as the ground ring can act as a conduit for EMI generated by welding. Temporary shielding, such as Faraday cages or electromagnetic shielding materials, can provide an additional layer of protection during welding activities. These materials create a barrier that attenuates electromagnetic waves, reducing the amount of EMI that reaches the communication equipment. It's essential to ensure that the shielding is properly grounded to maximize its effectiveness. When monitoring and communicating, EMI monitors can provide real-time data on the levels of electromagnetic interference in the vicinity of the communication equipment. This information can be used to identify potential problems and take corrective action. Regular monitoring of the equipment's performance can help to detect any subtle issues that may be caused by EMI. Informing the welders about the presence of sensitive electronics and the need for precautions is crucial for preventing accidental damage or interference. Coordinating welding activities can minimize the impact on the equipment by scheduling welding during off hours or when the equipment is not in use. Additional considerations also play a role in minimizing interference. Scheduling welding activities during off hours or when communications equipment is not in use can significantly reduce the risk of disruption. Using the lowest welding currents and shortest arc times possible minimizes the amount of EMI generated by the welding process. Shielded metal arc welding, or SMAW, and gas metal arc welding, or GMAW, with low inductance cables are welding techniques that produce lower levels of EMI compared to other methods. Low inductance cables help to reduce the generation of magnetic fields, which can contribute to EMI. Minimizing the use of arc gouging or plasma cutting is beneficial because these processes generate higher levels of EMI than other welding techniques. Arc gouging and plasma cutting involve the use of high-energy arcs, which can produce significant electromagnetic radiation. Remember, welding generates electromagnetic fields because of the high currents used. These fields can induce currents in nearby conductors, including the steel structure of the building and the wiring within the communication equipment. These induced currents can interfere with the operation of the equipment, leading to data errors, communication disruptions, and even equipment damage. The ground ring around the perimeter of the building is intended to provide a low impedance path for fault currents to flow to ground, but it can also act as a conductor for EMI. The steel structure of the building is also an excellent conductor of electricity and can transmit EMI throughout the building. The communication equipment is particularly vulnerable to EMI because it operates with low voltage signals and is often highly sensitive to electromagnetic interference. Welding currents can be quite high, ranging from tens to hundreds of amps, depending on the welding process and the thickness of the materials being joined. These high currents generate strong magnetic fields that can extend several meters from the welding arc. The frequency of the EMI generated by welding can range from a few kilohertz to several megahertz, depending on the welding process and the equipment being used. This frequency range overlaps with the operating frequencies of many communication devices, making them susceptible to interference. Faraday cages are enclosures made of conductive material that are designed to block electromagnetic fields. They work by creating a barrier that prevents electromagnetic waves from entering or leaving the enclosure. The effectiveness of a Faraday cage depends on the conductivity of the material, the size and shape of the enclosure, and the frequency of the electromagnetic waves. Electromagnetic shielding materials are used to attenuate electromagnetic waves. These materials can be made of various metals, such as copper, aluminum, and steel, and are often used to line enclosures or to wrap cables. The effectiveness of electromagnetic shielding materials depends on the material's conductivity, thickness, and permeability. Surge protectors are devices that protect electronic equipment from voltage spikes and transient currents. They work by diverting excess voltage away from the equipment, preventing damage to sensitive components. Surge protectors are typically rated in terms of their clamping voltage, which is the voltage at which they begin to divert current. Isolation transformers provide galvanic isolation, meaning they break the direct electrical connection between the power source and the equipment. This helps to block the flow of common mode noise and transient currents. Isolation transformers are typically rated in terms of their voltage and current capacity. Fiber optic cables transmit data using light signals rather than electrical signals. This makes them immune to EMI. Fiber optic cables are available in various types, including single-mode and multi-mode, and are typically rated in terms of their bandwidth and distance. EMI monitors are devices that measure the levels of electromagnetic interference in a particular location. They can be used to detect and quantify any interference that may be affecting the communication equipment. EMI monitors are typically rated in terms of their frequency range and sensitivity. Shielded metal arc welding, or SMAW, is a welding process that uses a consumable electrode coated in flux to create the weld. The flux provides a protective atmosphere around the weld, preventing oxidation and contamination. SMAW is a versatile welding process that can be used on a variety of metals. Gas metal arc welding, or GMAW, is a welding process that uses a continuous wire electrode and a shielding gas to create the weld. The shielding gas protects the weld from oxidation and contamination. GMO is a fast and efficient welding process that can be used on a variety of metals. Arc gouging is a process that uses an electric arc to remove metal. It is often used to remove welds or to prepare metal for welding. Arc gouging generates high levels of EMI. Plasma cutting is a process that uses a high-temperature plasma arc to cut metal. It is often used to cut thick materials or to create complex shapes. Plasma cutting generates high levels of EMI. A ground rod is a metal rod that is driven into the ground to provide a connection to earth. It is used to ground electrical equipment and to provide a path for fault currents to flow to ground. Ground rods are typically made of copper or steel and are available in various lengths and diameters. The lowest welding currents and shortest arc times can minimize EMI. Also consider a welding procedure that has preheating to shorten the overall welding time. Preheating is an indirect process where you heat the metal near the welding joint to the specific temperature you want for the weld. Proper grounding is critical, ensuring that all equipment is properly grounded to a single point ground. This can help to minimize the effects of EMI. Also, using appropriate filters on power lines can help to reduce the amount of EMI that is conducted into the equipment. Finally, regular inspections of the welding equipment can ensure that it is in good working order and is not generating excessive EMI. Proper ventilation of the welding area is important to remove fumes and gases that can be harmful to workers. Workers should wear appropriate personal protective equipment, or PPE, including eye protection, hearing protection, and respiratory protection. The welding area should be clearly marked with warning signs to alert others to the potential hazards. Welding should be performed in accordance with all applicable safety regulations and codes. A comprehensive approach to minimize the impact of welding on communication equipment is essential, combining physical and electrical isolation, grounding techniques, shielding, monitoring, communication, and adherence to best practices.